In this video, we're going to cover covalent bonding. But before we get started, a couple of reminders. Compounds occur when two or more elements chemically combine to make a new substance, like water or salt. There are two ways that compounds are formed. One of those is ionic bonding, which we already covered. In ionic bonding, you have atoms that have gained and lost electrons, and then they become charged. And then the opposite charges attract, stick together, and make a compound. Today we're going to cover covalent bonding, which is the other way that compounds are formed. In covalent bonding, instead of atoms giving or taking electrons from other atoms, they actually share their outside electrons. We're going to take a look at how that works. First, we're going to use fluorine. Fluorine is number 9. It's one of the halogens on the periodic table. We're going to draw our model of fluorine, number 9, so it has 9 protons, 9 positive charges in the nucleus, but it also, because it's an atom and atoms are neutrally charged, it has 9 electrons or 9 negative charges. 2 of those electrons go in the first energy level, according to Niels Bohr. And then in the second energy level, we could have 8, but because fluorine has 9 electrons, there will be 7 of those electrons in the outer energy level. And that means that there's a space where there could be another electron, but there isn't. Now we're going to take this and duplicate it. We're going to draw another fluorine atom with its 2 electrons in the first energy level and 7 valence electrons or electrons on the outside energy level. And it also has that one blank space where there could be an electron, but there isn't. If fluorine gets close to another atom of fluorine, they can share. And that means that this electron shares here and this one shares here. And as long as they are sharing those electrons, each of them behaves as if it has an outside energy level that's complete. But because that's happening, they have to stay together because they're sharing. They can't share far apart. They have to share by being connected to each other. This is one example. If you were looking at the formula for this example, it would look like this, because it's 2 fluorine atoms, and that's what this number means. It comes after the symbol for whatever element we're looking at. We're going to take a look at one that's a little bit more familiar to us. We're going to look first at an atom of oxygen. Oxygen is number 8 on the periodic table, which means it has 8 protons. If it has 8 protons or 8 positive charges, it will also have 8 electrons or 8 negative charges. So it has 1, 2, 3, 4, 5, and 6. It has 2 blank spaces where it could have electrons, but it doesn't. So it can find other atoms that have an electron that it can share, and then it can stick together. Luckily for us, we have something called hydrogen. Hydrogen is up here. It's number 1. It has 1 proton and 1 electron, but it has a blank space as well, because if you remember, the first energy level can hold 2 electrons. So it has 1 and it has 1 blank space. If it gets close to oxygen and there's enough energy, it can actually share its 1 electron with oxygen to fill in that space, and oxygen will share 1 of its electrons with hydrogen to fill in that space. In this case, hydrogen now has a complete outer energy level as long as it continues to share. But oxygen doesn't. It still has 1 blank space. So if it finds another hydrogen atom, it can do the same thing. And if it shares with this hydrogen and this hydrogen, then oxygen is happy, and so are both of the hydrogen atoms. That's how we end up with something that we refer to as H2O, or water, also called dihydrogen monoxide, which sounds a whole lot scarier, but it's not. We actually need water. So that's how covalent bonding works, and hopefully that makes sense. The biggest difference between ionic compounds and covalently bonded compounds is that in ionic compounds, the atoms give and take electrons becoming charged. In covalent bonding, they share. So the charge doesn't change, they just have to stay together in order to share those outside electrons. There are a couple of other things that you should know. Covalent bonds also create compounds that have certain properties. And those properties or characteristics, things that are common among those compounds, are that they have a low boiling point. Boiling point is when something goes from its liquid state to its gas state. So for instance, the boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. 212 degrees Fahrenheit seems like a high temperature for us. It would be miserable and hot, but it's a low boiling point for a substance. They also are good insulators. That means that they can prevent heat and electricity from moving through a substance. So hopefully that makes sense to you. Hopefully that distinguishes between ionic bonding and covalent bonding.